Hi everyone. Today I thought that I'd just go over a few strategies to design solutions to problems involving loops. Loops are particularly challenging just in terms of dealing with different variations to the control flow as you're iterating. And with nested loops, it becomes quite a bit more difficult, particularly as we're moving towards arrays, and arrays can have various ways of representing in memory, depending on the collection or the amount of elements that you have to store and represent, right? So, focusing on design as a skill will serve you very well moving forward with, tackling and solving these types of problems a little bit more efficiently. And that's the key, is just minimizing the amount of time that you spend implementing the solution by focusing on creating a good design. So that being said, I thought I'd illustrate this with an activity. So for the remaining week, you can upload your own problem, which I can implement in Mimmer for you, and you'll be the author of that problem. And we'll just add that to a pool, meaning that for any new students that happen to join the course a little bit later throughout the year, they'll have access to your problem and they'll be able to solve it. Now, in order to do this, you'll need to create both a problem prompt and the solution to that problem. So, here's a few steps, and I've added the link also to draw.io if you want to try it out as a way of sketching. Another technique is just to find a whiteboard somewhere on campus or just pen and paper and sketching, some diagrams that illustrate how data changes and how the control flow changes as you're kind of thinking about your solution. But as an example, I thought that I'd use a use case where given a string of, they're given an array of strings, so a series of strings read from the input to the console, you would have to then return as output the count of each unique string, so eliminating, of course, duplicates. So let's say that we had a simple example here. So as string, I might begin in terms of my test case by just imagining, well, I'll give you a string of a known amount. So let's say three strings. And maybe the first value is apple. The second value might be banana. And then third value is apple. And what I want to print as output, kind of something like this. So since we have two apples, I'll just write the count next to the string. So apple 2, banana 1. So that's a simple test case example. Now, in order to translate this input to an output value, we'll need to perform a few different processing tasks. The first will probably just be trying to capture all of the strings, the known amount of strings, to an array, so that we can do something to the array at a later point. Now, let's start off here by just illustrating how we'll capture our inputs. So we have a value of 3 coming in as input, an integer, and we might store that in a variable. Let's call it count. So we'll initialize count to an integer read from the console. So in memory, we'll have count assigned a value of 3, right? So I'll get rid of the test case example for now, but we'll revisit that a little bit later. For now, I just want to focus on designing my solution here. So I can assume from the series of 3 integers that, well, since I have now the count variable, right, to keep track of the length, which might vary depending on the test case, probably have to initialize here an array to hold all of the strings. So that array we can call it product. And we'll initialize that to a length of the count variable over here. All right, so in terms of the control flow, I'll just kind of indicate that by a little arrow. So next step, now that we know the length of the array, we can set up a loop. Oops. And here I'm just going to focus on the termination condition for that loop. So we probably want to iterate over the entire length of the array. So remember, an array has a length property. So I being smaller than product.length, we'll increment I at each step. And as long as the condition is true, we'll perform a certain action. In this case, we might have to set the value of the array here that we've just initialized. So we've called that product, right? So in memory, we have a reference variable. And the default value to this, since it's a string array, is just 3 null values. So we haven't set the value of our string array yet, but we'll do that within the loop. Bring that over here. And let's say, based on our test case that we reviewed previously, like the first value was like apple, right? It was like apple, orange, and apple, let's say. So we can just imagine that once this loop has been used to capture all of the inputs, like in memory, most likely our array is going to look something like this. So here we have apple, orange, apple. And mind you, these strings would be included on the heap. And so what's actually stored in the array are the actual address of where the sequence of characters is stored, right? But just trying to be a little bit quicker here in terms of the sketch. Doesn't need to be perfect. It's really just more of an aid to kind of help you keep track of things. There you go. So once the termination condition here returns false, is where we'll stop the execution of our loop, and we can assume that the array has been entirely filled. So we have apple, orange, and apple added to our array. So next, we probably need another array, an array to keep track of the name of non-duplicate strings. And we'll also need an array to keep track of the count of each of these strings, like the number of times that they were occurred, right? So we have like 2 counts for apple, 1 count for orange, so we'll need one array to store the unique names of these products, and another array to keep track of the count for each of them. So let's start off here with the names of the products. And the variable that we can use to call this, as long as it captures a little bit of its function, right? Let's call it list names. And remember, we have the count variable over here that captures the length of the array. So we can just assume that this array here will never be greater in terms of the length than the number of products, right? Since we're just using it to store the unique names. So it's fair to assume that it'll always be somewhat of a lesser amount. Now, mind you, that amount we don't know ahead of time, so we might have to initialize another variable to keep track of that information as well, since that's likely to vary from one test case to the next. So here in memory, now we have, oops, list names, all right. And since we've initialized it, default values for strings, 3 nulls. Now we might need another array, this time of integers to keep track of the count. Oops. Again, the name of the variable, it's a little bit arbitrary, but if we were to name it something like list counts or list totals, it might capture a little bit of its function. Let me see here if I can copy paste this over so we have that as reference. And what's the default value for integer arrays? 0, 0, and 0. So here we'll be filling in this array with information, right? But we're never quite sure the amount of information that'll be added. So we might have to keep track of this as we want to ensure that the process is somewhat efficient. So if we have to traverse through list names or list count to do something else, we probably don't want to traverse throughout the entire array. As let's say we have like 2 apples, 1 orange, then the first value here might be apple, the count might be 2. Second value here for list names might be orange, the count might be 1, and so we don't need to bother about the third element, which will be null and 0, as we haven't had a need to fill it out yet. So we're just using list names and list counts to keep track of the number of unique names. So we're not very interested in terms of the actual duplicate information. We only want to keep track of the unique names and their count. So let's use a counter variable for this. And what can we call this? Maybe list count. Let's try that. Now, we can probably assume initially that we'll have at least one value that's added to the list name and list counts. Even if we had a test case, where let's say we had like 3 apples in our product array, we can pretty much assume that at least there'll be one instance of one element with a value of apple and a count of 3. So we might as well initialize this variable to 1. Now I'm sure we can figure out the logic for, if we were to initialize it to 0, we might be able to update it at some point. But it just kind of makes sense to assume at this point that we'll have at least one unique name to add to our list. And as we encounter new unique names, we can just update it. So a list count will be available in memory here, store a value of 1. All right, so far, this is the whole logic for the solution that we've captured. So let's focus on the next part. And here we'll probably need to do a few things. Well, first we'll have to traverse throughout the product array to take a look at the strings that are stored. And so for this, we can assume that we'll need a loop, right? And we'll just increment I by 1 to traverse throughout the entire length of the product array. Now, what we want to take a look at is whether, for instance, let's say for the first iteration of the product array, we have a value of apple here. And what we really want to do is to compare it to the first value in list names and take a look at, well, if it's equal or not. If it's equal, then we're not dealing with the duplicate name. If it's not equal, then we'll probably have to add it to the list names just to keep track of it. However, list names can have like multiple terms, right? So we'll probably have to iterate throughout the entire array of product, and then comparing for any one of these products for the entire array of list names, but only to the length of list names as indicated by list count. So currently we have like one item, right? So we don't need to traverse throughout the entire array for list names. We only need to first compare for the first element. So let's think about that. So first of all, any one of these names can be either a unique name or a duplicate. So that information we might capture here by using a Boolean. And we can assume initially that if the value is set to false, so we're going to use a Boolean flag, if the value is set to false, then we can pretty much assume that, well, maybe it's not a duplicate at this point. So let's see, maybe a good variable name for our Boolean flag here might be target match. As in we have a target name and we want to see if it's a match or not. And initially we'll just assume that it's not, so it's a unique name. Okay, so next, so we've iterated through our array lists. We're taking a look at this first value here, apple. We can assume that it's a unique name, meaning that there's no matches. So we'll just assume and set our Boolean flag to false for that variable. Now, next we have to compare against list name. So to do this, we'll have to traverse throughout list name. So we'll need a separate loop, and it will have to be nested in that we need to do the comparison for each and every term in product. Now, again, the length of list name, so we're using the list count variable to keep track of that information. So we can probably start off by just saying j, as in it's a nested loop, so our counter variable here will be j, is lesser than list count, which currently is set to 1. So if we increment j by 1, for the first iteration here of our outer loop, it should iterate no more than once. And that will take care of comparing for each and every value here stored in list names. Now, mind you, next we have to handle the comparison. So if apple is equal to null, how might we implement that? So we'll need conditional statement. And we might start off here by looking at our product array, which we're traversing using I as our counter variable. So product at index I using the dot equals method, because it's an array of strings. So if you want to compare the actual content of the characters, we'll need to call the equals method. And here we'll type in list names using j as our index, which is captured here. And that we're using j to traverse through this array. But not the entire array, because our termination condition here is set to list count, right? So it's no more than the amount of values that we'll add to this array. So let's say here that the values happen to be equal. So we're using the Boolean flag to assume that they're a unique name. So if it's equal, then they're not unique, right? So we'll have to probably update our flag. And then indicate, okay, so variables are not unique. So we've obtained a match. So here we'll set target match to true. Okay. So if it's a match, remember we have to keep track of the counts, right? And the default value to list counts is 0 currently. So if it's a match, like let's say I have like apple here, and then I've matched it to the first value here, which just happens to be apple, I probably want to increment it, increment the count to reflect that, well, it's not a null value, it's not 0, so it should be 1, meaning that we've got a match. So to do this, we know that we'll have to access our list counts array. The index that we can use, probably the same as j, not I, right? Because we're using j to traverse through list names, and we probably want the indexes here to match and be aligned with each other. So list counts at index j. And probably need to increment that. All right, so once we've incremented, that's the only information that we need to keep track of, right? So that'll close off this loop here. Whoops. My loop is actually this one. Okay, so if this is true, right? So we have to have a use case here for our selection statement as to whether it's false and what we want to do with that. So let's say that it's false. Well, we probably want to check for the next item in our list counts array. So if product at index I dot equals list name at index j, so if we don't find any matches, so we probably want to evaluate for the next value here at index 1. So next up, our termination condition here. Kind of move this over here, keeping track of the control flow. Oops. Let's just push it to the side for now. Yep. All right. And this is a nested loop, right? So we're going to have another control flow scenario here to keep track of. Now, remember, so for the first iteration here, we're really comparing the first product, and we're traversing throughout the entire list of names in order to update and increment the count. So in this case here, once we've traversed throughout the entire list, before we move on to the next product name, now if we reach this statement here and our flag is still equal to false, that means that we haven't found any matches in our list yet, presumably, right? Because we're updating our Boolean flag to keep track of that condition. That means that we have a unique name that we probably want to store in our list. So how are we going to do that? Well, we probably want to check for the value of the flag. We've set it, we've initialized it here. Now we have to evaluate for that value. So we can use a conditional for this. So if the flag is set to false, we were previously working with the assumption that if our flag is set to a value of false here, that means that we have a unique name. So if it's unique, we'll have to invert our condition, right? Because false will be inverted to value of true, and then we'll execute whenever is in this branch. Now, I think that will work. Mind you, the devil is in the details, right? Once you implement the code and you go through the debugging process, we can start fixing some of these little assumptions. So if we have here a unique name, well, we know that we need to set the name over in list names, right? But what information can we use in terms of our index? The list count. So for the first name, it's set to 1. So if I go over here and I say we need to add the name to the array list names. In terms of our index, we have list count, but it's currently set to 1. So we probably want to reset that to 0, as in -1. And this will be equal to product, because we need to get the name from the product array over here. And we're still in the outermost loop, right? So the control flow here for the outermost loop is right over there. So we're still just terminating the innermost loop. So that means that we can use as our index the value of I. So I think that makes sense up until now. Now, let's see what else we have to do. So we've added the name of our unique product to the array. So we'll probably have to set the initial count, I would imagine. Notice how list counts, the default value is 0. So if we've added the name to our list names array, we also probably have to set the value here to be something else than 0, right? So if it's count, it should be set to 1. So if we go over here and we say list counts rather, we can use the same index, list count -1, since we want to align our arrays. List names and list counts should be set to the same index. But here, instead of the product name, probably just want to set it to a value of 1. Now, you might wonder, well, what about if we have like a duplicate name? Remember, the duplicate name is in this branch over here, where we increment the value. So for now, we only need to set the value, assuming it's a unique name, and set it to a count of 1. And am I missing anything here? Oh, so since our array has grown, so essentially what we've done so far is we've updated list names to be Apple. We've set the count here to 1, right? List count should now be set to 2 once we finish the first iteration of the outermost loop. Okay. So that means that we need to increment the list count variable. So if I go back, we'll just say list count and increment the value. Perfect. So that'll close off. Where is our loop? It's right over here. That'll close off the outermost loop. Yep. Come on. There you go. Here we go. And I think we've pretty much figured out the hardest logic. The next step will just be printing out the output. So you can see that closes off our outermost loop. Now we have this control flow that we need to account for. And here at this step, well, we can just print out the output. So we have the processing task here for keeping track of matches and incrementing list counts. We have this processing task here for updating the list of names for all the unique names and then setting the count to 1 initially. So next would be printing out the output. Now, if you remember the test case example, it was just listing the name, like a few spaces, and then the actual value. So here we can just create a new array. We'll use I as our counter variable because we're done with the nested loop, right? So here we're starting a completely new loop in the main method. So we don't have to worry about the scope of I. In terms of the length of the list, well, it's a little bit tricky here because we can't actually use the length of list names, right? We're likely to have like null values at the end because we're assuming that the actual length of list names is lesser than the product names. But we still have our list count variable. List count should be set to a value of 2, assuming for this use case, right? As in we have our first value is apple, the second will be orange. It might have been updated to a value of 3 at this step. So if it's a value of 3, I might just try and say -1 for list count. So again, not quite sure here at this point, but your design is never perfect. You're likely to make like logic errors because it's really hard to keep track of all this information, but it's kind of like a best guess scenario. So let's try I is lesser than list count -1. And if that's true, we'll print out the following. We'll just say list names at index of I, separate that with 2 spaces, and then list counts at index of I. There you go. And when this returns false, here we can just terminate execution of the program. So that's our endpoint. Now, typically you'd kind of like pause and think a little bit about, the steps that we've taken like so far. But I kind of feel pretty confident here in terms of implementing the solution in IntelliJ by going off of this initial design just to test it out and see if we have any logic errors that we need to fix and debug. So starting here from the very first step, I'll just bring up IntelliJ and we can kind of follow along here. And that's the main thing about having like a good design in place. It's pretty easy once you switch here to your code, and I'll just bring up IntelliJ so you can take a look. You kind of have it as a reference now. So helps you think in terms of, well, what's the series of steps here that you need to implement? I'll add in my header comment. There you go. We'll probably need to import our scanner, right? Oops. So using the scanner class, we'll just call the scanner KB. Let's see. All right, so what's our first step? So if we go back here to our design, and here I'll just kind of show you like once, so I don't have to toggle the screens every now and then. But the first step in our design was to initialize count to an integer read from the console. So you'd go back and forth in terms of your design while you're implementing your code. All right. All right, so back to IntelliJ. So here I'll just initialize count, an integer read from console. So int count kb.next int. Next, we'll need to initialize product, which was our string array. And we'll set that to the length of count. Next, we had our first loop to go about filling the array. We're using I as a counter variable, so I is equal to 0. Setting I to be lesser than the length of the product array. We'll increment I at each step. So if the termination condition returns true, we'll set our product array at the index of I to the value read from the console, which was a string. So in this case, product at index I would be equal to kb.next. Using the next method here, assuming of course that it's a contiguous series of characters, meaning that there's no spaces in the names. So that should fill the array. So next step in terms of our design, we had to initialize an initial array, list names, which will keep track of the unique names. So again, we can assume that that array is no longer than the product array. So here, we'll call this list names to the length of count. Next, we'll initialize the list counts, which was an array of integer. To the same length. And we had initialized also list count. Initially to a value of 1, right? So that was one of the things that I wasn't quite sure, but I think as long as we increment the value at each step, the way that we've designed determination conditions, should be fine. So we have our outer loop to traverse throughout the product array. So we'll set that to value of 0 for a counter variable. We were traversing throughout the length of our product array. So I is lesser than product.length, incrementing the value of I by 1 at each step. Next, we had designed the target match variable as a Boolean flag to keep track of whether or not the product was unique. So initially, we were assuming that it wasn't. So we would set the value here to false. Okay. So next we had our inner loop using j as our counter variable. And here designing determination conditions so that it iterates to no greater an amount than the current list, the current count of items added to the list name. So j is lesser than list count, incrementing j by 1 at each step. And within the inner loop is where we were evaluating whether the product name is equal to the current name added in list names. Whoops. Made a little error here. Opening, closing parentheses. There you go. List names at index of j, because we're using the inner loop to traverse throughout list names, the outer loop to traverse through product. Now, if there's a match, we had set here that we're going to update target match, right? To true. And since there was a match, here we needed to increment list counts. And in terms of our index, we're using j. So if target match is set to true, that means that it's not a unique name. We've incremented the count. However, if this happens to return false, then what we would do here is we would have to work with the assumption here that the Boolean wasn't updated, right? So in our next step, outside of the innermost loop, is where we would have to check whether or not this is the case. Now, if it's false, so that means that it's unique, right? So false meaning that it's unique, so we'll have to invert our condition. So a false will be inverted to value of true, meaning that we'll execute this code. So if it's a unique name, then we need to add it to list names, our array. And we'll get probably the name here from the products using I as our index. Here we have to use list count minus 1, right? Because list count is initially set to a value of 1. But we probably want the index to be like 0 for list names, meaning that we'll add it as our first element. And here we'll use list total, list count minus 1 is equal to 1. Oh, one little error here in terms of the syntax. It's not list total, it's list count. So list counts at the same index will be equal to 1, assuming, of course, that the product name is unique, so to count at least one occurrence. And at that step, we'll need to update the list count variable. Because now we should be evaluating for the case where we have 2 items. At which point we'll evaluate here for the second item at product length and the second iteration of the outermost loop. Okay, so in terms of the next item here in our control flow diagram, we reach the case now where we traverse through both list names and list counts to print the values. So this is another place where I was a little bit confused here. So list count, we can try it out. So I is equal to 0, I is lesser than list count, and then I kind of think that we should set it to minus 1 here, I plus plus. And here, print out the values. So list names at index I, 2 spaces followed by list total at index I. Ah, why list total? List counts. All right, so if we try out our first test case and try to run this, we have 3 items: apple, banana, and apple. So what that returns is 2 apples, 1 banana. So that seems to work. If we try it again with a different test case, 5, as in apple, 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 banana, grapefruit. So we have 3 apples, 1 banana, 1 grapefruit. I think one of the tricky things that I wasn't quite sure about was in terms of designing this termination condition here for list count. So if we weren't to include minus 1, what might happen in this case is if I type in 3, yeah, you see it captures the null value. And that's really the remaining value that's included in list names and list counts. And the reason for that is really because we had set initially a list count to value of 1. So it should be updated now to a value of 3. And that's why it's traversing throughout index 0, 1, and 2. So to avoid that little problem, minus 1 was the right step here. And you can notice, we've kind of used the same approach here to set the value as well. So the logic seems to be pretty consistent across. All right, so now we have the correct code for the solution. We've tested with a few test cases. Now, what I'd like to invite you to do is in Mimmer, if you'd like to create your own problem for other students to solve in class, you can send me the code. So all of this code solution here, the Java source file, along with just a little bit of information for the problem prompt itself, like in the form of a comment. So if I were here to, add a multi-line comment, probably what I'd create for like the problem prompt here, if you really want to make it like short and sweet, it could be like, write a program that returns the count of non-duplicate string values from a, oh, here, well, that might be enough. Write a program that returns the count of non-duplicate string values from a collection or series of strings. And then list your test case examples, because those I'll have to add as a table in Mimmer. So if we type in 3, banana, apple, and apple as input, the corresponding output would be banana and 2 spaces 1, apple 2 spaces and 2. And for good measure, you might want to include, a few extra ones to help out the students. It's always best to include at least 2 or 3. So if I were to say 4, banana, apple, 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 in terms of output, that would be banana 1, apple 3. And that's all the information that you need to send along. So once you've done this, I'll just set up the problem in Mimmer for others to solve. And I'll add you as the author of that problem in the description for the problem prompt. And you get to have like bonus marks for practicing with this. What I'd like you also to submit is your control flow diagram. I think the key point that I'm trying to make here is how absolutely useful and essential just sketching out solutions to problems is, right? So by relying on these types of sketches, it helps you kind of manage all of the information, keep track of all the steps, and you can kind of reason about your solution a little bit more efficiently than having to worry about the syntax. Keeping track of all the most relevant details, I'll make this available as an image for you as a resource for you to think about. And again, you're totally free to participate and opt in, so this is like an optional exercise. But I thought that would be fun as a fun activity to do during the weekend since you don't have any assignments other than the PODs assigned. So if you want to try it out, have fun. You can design any type of problem that you want. If you submit it to me, I'll just index it based on the type of procedure that's required to solve it. I'll add it to Mimmer, and yeah, you get bonus points. So I hope that you enjoy the weekend and take care.